And I meant to start with that, so I apologize for not doing that. I have to also, there's a message from somebody in the class, I need to reply to it. Okay, so if you have a technical problem, just email me and I'll respond to it and try to see what I can do about it. I do intend to record the lecture, and I just forgot at the beginning of this one, so the rest of it will be recorded. So anyway, so I apologize for the break. Okay. So anyway, so it's just a simple problem, but when you think about it, it connects to like this weird, in a weird way, to a problem that's like over 2,000 years later. A riddle, who knows if there's a connection. And it also, the way that they did it suggests a deeper knowledge of mathematics than you might think. Now, I'm not saying they understood infinite series and pi and binary mathematics, but they understood aspects of those things, at least the finite version of the series. Okay, so any questions or comments? I am going to share the next screen and just briefly, and then I'm going to go over the problem because it's weird. And I think hearing it and seeing somebody do it is better than just the handout, but I want to start with the handout. And then there'll be some problems on that handout for people to break into groups to do. So here's the, oops, that's the same problem. Let's see, what am I sharing? Okay. I'll have you look at this for a second, and I'll try to make it a little bit bigger. Okay, so you can, this is the, it says how to write 2/7 as a sum of unit fractions. If you're not,
it's, you mean on the dog camera or what you're sharing?
What I'm sharing.
It's barely, you can't see anything. It's like just the top bar of it.
Okay.
At least that's what's happening to me.
Okay.
Yeah, that's what I see too.
Okay, let me try to reshare it then. I'm going to stop the share. Okay, we don't need to see the whole thing, so I'm going to try that again. And this is the second handout, so you can also download it from Blackboard if you want. It's handout number 2. How's this? Is this better?
Yep, that's good.
Okay, good. I think I know what it is. I think if I change it, it doesn't always. I was switching it from Windows. Okay, so this is going to be indecipherable. What they're saying here, if you look down, if you can see it, 2/7 equals 1/4 plus 1/28. That's what they're proving here. And these are the computations. And I think if you just look at it cold, it's not going to make any sense. So I'm going to walk through those computations, and then there's going to be 3 problems where you do something similar. This is the problem, and the papyrus starts off with a bunch of calculations about taking a fraction that's 2 over an odd number and writing it as a sum of 1 overs, of reciprocals or unit fractions. And then the sort of the introduction, I mentioned this in the introduction, and it showed why they might have done this or wanted to. And it turns out it's a very good way to share something, at least for when the numbers are manageable. If you wanted to share 2 things among 7 people, you'd give each of them a quarter, and then a 1/28th, and then 1 over a quarter and a quarter and a 28th. It's hard to share a 28th of something, but that's the idea. That's what they're saying. I think in practicality, they would have probably, if they were going to share something 7 things 2 ways, they would give each person a little bit less than a quarter, I think is how they would use it. But there's some pictures in that about how they did that. I'll let you look at that. So you can, if you want, I'll leave it up to you what you want to do. No, I don't think you can pin when I do this. So I'm going to stop sharing this in a minute, but download it so you can look at it from the website, and we'll come back to it. And I don't know if that's going to be a problem for people or not to do that, but that's I'm hoping you can do that. Or as we get more used to the rhythm of things, you can print it out before class if that's easier for you. So download this from Blackboard, that's handout number 2, and share it, and then I'm going to go back to the document camera. Okay. So this is what that problem is proving. And I want to go through the calculation and how I look at it. And it's multiplying. It works similarly to the multiplication table. Okay. So you start with 1 over 7, and then you take half and sometimes a half is written this way with 2 with a bar over it. That's like, I think I mentioned that last class. That's the sort of standard way that historians write, to indicate they're using Egyptian notation. I think we can use modern notation. And so I'm going to get 3 1/2 here. Okay. Now, what I'm hoping, if I magically hit 2 here, it means that 1 over something times 7 is equal to 2, which is 2/7. So I'll go through all that. So we're going to take I'm going to take half of a half, multiply by 1/4, and I'm going to divide this in half. And this saying is that 1/4 of 7 is really not quite 2/7, a little bit short. And so here's where things get weird. The text does something like this and puts 1/4 here. And then they go over to the side, they go over to the side, 4 times 7 is 28, and they go through the multiplication. I'm not going to. And then they say the answer is 2/7 are equal to 1/4 and 1 over 28. So that's what they do. So what I want to do is kind of give you an example, to help you understand what's going on here. And so remember, it's kind of the opposite of multiplication. What we're looking for, if this number gets to be a 2, then we know that 2 over 7 is equal to this, would be equal to that number. Okay, so right here we're saying that 1/4 of 7 is equal to 3/2. 7 is equal to 3/12. Sorry. Seven-eighths, sorry. And that tells me 7 is equal to 7/8 times 4. Sorry, I'm not doing that very well. Let me do that again. Okay. So what I'm saying in that column there is that 1/4 times 7 is equal to 7 over 4. So that's what that column says. Now, if I got lucky and I said that some magical number times 7 is equal to 2, then I would get that 1 over m is equal to 2 over 7. And that's not going to happen because 2 and 7 don't work out that way. So what they do is here what I want columns here that add up to 2. So what I do is I say, okay, I'm going to say that I'm putting a fraction here. So I'm saying that 1 over n times 7 is going to be equal to 1/4. So that means that if I solve for n, I get multiply both sides by 4, I get 28. Multiply both sides by 7, I get 28. I get n is equal to 28. So it turns out that 1/4 of 7 is 1/2 plus 1/4. 1/20. Sorry, oh, was there a question? No.
It's just what you're writing isn't on the camera.
Yeah, thank you. Okay, so 1/28 of 7 is equal to 1/4. That's what this shows. So 1/4 plus 1/28 of 7 is equal to 1, 1/2, 1/4 plus 1/4, which is 2. So it's a really convoluted way of figuring out a fraction. But again, the algorithm is you keep going down till you get close to 2, and you realize it's not going to help. So then what the Egyptians did is they put, okay, whatever goes here, I want whatever goes here to be equal to 1/4 of 7. And so whether they did it, what they figured out that I just need to multiply this number times, just need to multiply this 4, whatever number's here, times 7 to get whatever that number equals. And I'll do another one just so you get a sense of it. And so if we go back to the screen share, that's what they're showing here. They're showing that they go through the table and they get, okay, 1/4 of 7 is 1/2 plus 1/4. And then what they're trying to indicate over here is that 1/28 of 7 is 1/4. And then this is their check. Over here, they're doing that multiplication. 4 times 7 is equal to 28. And I'm going to do another example to try to illustrate it. But are there questions beforehand? Like I say, it's very convoluted and it takes a couple of times to do it. And we're going to break into groups in a couple of minutes and have you do it.
I have a quick question.
Sure.
So is there a reason that they did it this way? Because this seems a lot less intuitive than, I guess, the way that we do it.
Because they wanted to divide a fraction that's 2 over something into a sum of unit fractions. As a way, and for whatever reason why, we don't know exactly why they did it. If you look at the examples from the introductory lecture, for some of these, there's practical applications for it because it helps you to divide things up. But this is the way they wrote fractions. If they had like 4/7, they might do something like this. We know that 2/7 is equal to 1/4 over 1/28. 4/7 would be equal to double that, 2/4 over 2/28, which is 1/2 plus 1/14. And if they had 5/7, That's equal to 1/7 plus 4/7. So we know what 4/7 is. So basically, for whatever reason, what they're saying is this. And we don't know why they did it. Like they didn't say we're doing it this way because, they're not as self-reflective as modern, modern culture, I guess. But Dan, does that help, Daniel?
Yeah. Thank you.
And it's weird. And I think when we go over another one, we'll do it this way. And what's even weirder is that until about the 1600s, from what I read, this was how people wrote fractions. Like Fibonacci wrote a book in around 1200 introducing Arabic mathematics to Europe as an advanced calculational system. And he still talked about unit fractions. It wasn't until decimals came in about 1600, and decimals came in as sort of as a tool of commerce because it made calculations easier, that people got rid of this. It's weird. Okay. So I'm going to do 2/5. And we're going to see what that equals. Okay. So I do the same thing. Okay. Then take 1/2. Take 1/4. I may regret this. Take 1/8. Okay, that's good. Okay. So remember, my goal is to get, if I'm totally lucky, which I'm not going to be very often, this is going to add up to 2. Because remember, this is saying that 1/4 of 5 is going to be equal to 1/1/8. And then 1/8 of 5 is equal to 1/2 plus 1/4. So what we know from this, we're short. How much are we short there? Remember that bar means fraction. It's just a habit for me, I'm sorry. We're short 1/8, right? Because if I add these two numbers up, I get 1 and 7/8. So this is how much I lack. That's how much I'm short of 2. So I'm completing the 2. Okay. Now I have to solve this. And so I know that, so the algorithm says that, okay, I know I want to solve this. And we're doing this the way we do it. So what's n equal to?
$40.
Okay, I think I made a mistake earlier. I'll go back to that. And it might be a crucial mistake.
I think the 1/4 should be 1 1/4, not 1 1/8.
You're right. Okay.
And then that probably changes the next few as well.
Yeah, that's going to be 1/8 right there. I'm just double checking my math to make sure it's right. That's correct, right? 1/4, 1/2, 1/8. Yep. Half of that's that, half of that's that. Okay. Luckily, I'm still short an 1/8. So it's going to be the same. I think I transposed is what I might have done there. I don't know. But so if I add these two together, I'm going to get 1 plus 1/4, 1/2 plus 1/8. These fractions again add up to 7/8. So I still need to find this. And so n is going to be equal to 40, as we just showed. So that means that this number is 1/40. So 40 over n, just to be, I mean bar 40, just to be consistent. So again, the idea is 1/4 of 5 is 1 1/4. 1/8 of 5 is 1/2 plus 1/8. And then 1/40 of 5 is equal to 1/8. So basically, this fraction of 5 is equal to 2. So 2 over 5 is equal to 1/4, 1/8, 1/40. Okay. Okay. So is it, how is this in terms of making sense?
So yeah, just to clarify, you try to add up as much as you can, and then you just try to find an end that'll work for whatever is missing.
Right. And it has to be something like that. Whatever number we put here, or here, I guess, it has to be a unit fraction. If we're short like 2/3, that's not going to work. It has to be 1/. And so I have a copy, you know, this is like this is a copy of the papyrus. The library has it. I can give it, and it has all the problems from we're working from the Ames papyrus. It has all the problems in there, and they do this with remarkable efficiency, and there's all kinds of patterns in here, and we'll hopefully explore some of those today. But it's really intricate mathematics. I mean, it's not straightforward, as Daniel pointed out, but it's intricate, and it shows some skill. This is not something that you just say, oh, that's trivial. You have to think about it. And there's more than one way to find a unit fraction decomposition. Okay, so I'm gonna I think we're okay. Makes some sense, good, okay. So I'm gonna just break you into groups, and I'll do 4 groups, because that makes it easy for me to see. And if you go back to that handout, I'm asking you to do 3 problems, and the Egyptians didn't always start with 1/2, and they sometimes divided by 1/3. So it's, you know, it's not always done the same way. There's an art to it, you know. And then, as you see, you know, so I'm giving some hints here. So I'm going to break you into groups, and I'll join each group and have you work on those problems. Now, I assume everybody has a copy of the handout. If not, let me know if you want to copy this down. You should be able to, you know, capture it and then paste it into a document. But unless if somebody says something in the next few seconds, I'm gonna stop sharing, and I'll walk and I'll assume that you have it in front of you, and that you can go over this, and I'll help you with these too.
So I don't know how the rest of the class is feeling about this, but I know I would benefit from seeing one more example.
Sure, let's do the first one.
I agree.
Okay, that's fine. I really need that kind of feedback, so that's really helpful. Is the document camera working as long as I stay on the page?
Yes.
Good.
Yes.
So 2/13, and what does it say to start with?
1/2.
And then what does it say? Anything?
Nope.
Okay. So I'm going to let you do it to a point where you stop, and then I'll do it. So go through the algorithm until you feel you're close to 2. And then I'll do it. I'll present it, and give me, like, 30 seconds or so. I want you to work on it a little bit on your own. And this has a wrinkle in it, so it's a level up. Okay. Okay. So I hope everybody got that far. Okay. Now, I'm going to try 1/16, and I get 1/2. I'm short 3/4, or I'm sorry, I'm short 3/8. And I can't solve for 3/8 here because it's not a unit fraction. So I'm gonna see what happens if I go a couple more. I don't like how this is looking. Okay, so I'm short what? How much? 3/8, right?
What's the goal again with these fractions? Like what number do we want it to add up to?
2. Because remember what we're doing is we're saying, I'm going to use an x. X equals 2 over 13. 13 times x is equal to 2. Now what our x here is going to be a sum. It's not going to be a simple number. It's going to be a sum of numbers. Okay. And I probably should have said it. I probably should have done that before. Okay. So anybody have an idea on how to improvise and maybe how to modify what we did before to make it work here? And you can either write it out, because we're short 3/8. And can you think of a way to write 3/8 as unit fractions? Right? So I need this and I need this. This is how much I'm short. So what I'm going to do is I'm going to solve 2 equations, not just one. So I'm going to say, okay, I need to solve this. 1m of 13 is equal to 1/4, and 1n of 13 is equal to 1/8. So you can either, shout it out or type it. So what do you get for m? And what do you get for n?
You get 52 for M, right?
Yeah.
And then 104 for N.
Yeah. Okay. So m, we said this would be 1 over 54, and n would be 1 over 108. So these are the ones that matter to me. I can throw out all the other ones. And so I get 1/8 here of 13 is equal to 1 1/2 1/8. 1/54 of 13 is equal to 1 over 4. 1 1/08 of 13 is equal to 1 over 8. So 1/8 plus 1/54 plus 1 1/08 of 13 is equal to 2, because that's what these all sum to. So this is my x from up here.
Why did we go from 52 to 54 and 104 to 108?
Because I probably transposed. It's just the way my bizarre mind works. Sorry about that.
Also, why did we stop at the 1/8? That's the part I was kind of confused on.
You mean right here?
Yeah, why didn't we use the one for 1/16 or 1?
Oh. First of all, it's going to give me too much because I got the 1/2 here.
Okay.
That's going to be over 2. And I don't know what's going to happen here, but it's getting into fractions which are too big.
Hmm.
It could, you know, as you see, it turns out this will be a little bit bigger because all we need is a quarter and an eighth. That's going to be a little bit bigger.
Hmm.
This plus this is going to be slightly bigger than 2. And I assume that if I go to 64, I'm going to be slightly less than 2.
Okay.
So it looks to me that like I'm doing this and I'm getting discouraged. I'm saying this isn't going to work. So I'm going to try this method instead, because you're always going to stop somewhere short of your goal. Because the reason these don't work is because 2 over an odd number doesn't reduce. And so you'd really have to use some kind of infinite series of fractions to get the exactly 2. And you'd have to do this infinitely often and pick down a path which gets you 2, which is hard, especially if you don't even know what an infinite series is. So the idea is that they develop these tricks. They're saying, okay, this isn't going to work, but all I need is 1/4, 1/8. I've done enough of this with other problems. So why don't I go for 2 this time instead of just, why don't I go for a sum of 3 fractions? And that's fine. You'll see some of these decompositions are 4.
And then is there a fraction that like, are there certain fractions that just this will not work for no matter what you do?
I don't think so.
Okay.
It's a good question. I've never thought of that before. There's people have written mathematical papers on this, and if you Google Egyptian fractions or unit fraction decomposition, they're often called Egyptian fractions. You'll see there's like lots and lots and lots of stuff on that. And there's more than one way to sort of to do it. I mean, not sort of do it. There's more than one way to get. There's more than one answer. Okay. So you feel better about this? Okay. And again, sorry about the typos. They are going to happen, and I'll try to minimize those. Okay. So I'm looking at I work these out. Yeah, I think the next 2 are, and I'll break you into groups for this. Actually, yeah, I'd like to break you into groups. There's 2 over 15, and then 2 over 21, and the handout has the instructions on those. I'll let you work on those. So okay, so I'm going to break you into 4 groups. If you just want to pick one of these to work on, that's fine. 2 over 15 is going to be easier. 2 over 21 it's a lot of work. No, it's not too bad. Okay. But before I do that, any questions? Okay, good. What I'm doing this for is because the breakout room has disappeared. Let me try somewhere else. Yeah, that's a new one on me. There's usually something for a breakout room, and it's just not here. So so we're not going to do that. So it's always something. So like I was going to say divide yourself up into groups or 2, but you can't. So why don't you try these things? Try 2 over 15 and look at the hint, and try 2 over 21 and look at that hint. It's really bizarre.
I have a question for the 2/15.
Yeah.
So on the left-hand column, after you do like 1/10, is your next number going to be like 1/100
Well,
or?
let's see. On that sheet, let me go find the sheet. They didn't always do 1/2. Sometimes they did 1/3. And so the 2/15, you start with 1/10, and then you take 1/3 rather than 1/2.
So does it become 1/30 then?
Yes, yeah. So I'll show you on the camera. So you do 1/10, and you're going to get 1 1/2. And then you do 1/3 of that is 1/30. And then that's going to end up being 1/2. It's hard to do it from here it's hard if you take 1/3 of 1, you're going to get 1/3. And if you take a 1/3 of 1/2, you get 1/6, and that's going to give you 1/2. So again, it's clever, right? You know, like the scribe knew when to deviate from the rules, like a good programmer, right? You don't always do things the same way. Okay. So the last one is 2/21. I'll let you work on that. That's a longer one. This was a reward. And again, they started with 2/3, and then from there, you're not going to like the way they did it. So the way that you probably want to do it is to start taking halves from 2/3. Or if you want to, you can start with 1/3, I guess. But they started with 2/3.
And just a question. So is there any way to apply something that is at least kind of like this for stuff that is not 2/something, say 3/something?
Well, what you would do with 3/something, you would break it into, like, you had 3/15. You would break it into 1/15. This is what we think they did. And then 2/15. So this one's already done for you. And then you would just have to do 2/15.
Oh, okay.
Yeah. And you can do this, you know, you can build it up pretty far. Because
If you want to go one up, you just keep doing the 2s kind of thing.
and then you would double. So if you do 4/15, it would be 2 times 2/15. And then whatever we got for here, we got 1, it would be, so it'd be 2/1. And then you'd further reduce. So 1/5 plus 1/15. Because right here, this tells us that 2/15, since these add up to 2, is equal to 1/10 plus 1/30. And, you know, we would cheat. If you're just doing it the way we would look at fractions, that's pretty easy.
Yeah. Yeah, okay, that makes sense. Thanks.
So I'll let you work on 121. I had to go just so you know, I went down pretty far. It was like 4, and then I had to punt. You know, it was pretty obvious what I needed to find. So it just took a while, but it wasn't that bad.
Do we have any idea why they made an exception for 2/3?
Oh, no. Again, like they didn't document there enough about what, you know, one of the things to keep in mind is that papyrus is really, really super brittle. And they lived, you know, and they lived in a hot, dry climate, except during, you know, the flooding seasons and things. And so it's not made to last. And so we just don't have much documentation from them. We have the buildings, and we have things like the Rosetta Stone, and there's a few papyri, but like if you can imagine that stuff's, you know, leave a piece of paper out in the sun for a few years, you know, for an experiment, you know, and it's going to fall apart. So just because of what they wrote on these papyrus, which are these papers that are made out of, there's actually a technical word for it. They're not paper, but they're made out of plant fibers. They're made a little bit differently than people make paper. That they're just not, you know, they don't last. So I'm not sure where they found these, like whether they found them in tombs, or I think all that's shrouded mystery, because it's kind of shady how some of the Europeans got a hold of these things.
It's just kind of, it's amazing that we have anything at all.
Yeah. And we're going to see this with the Greeks as well. They used papyrus. You know, they're so smart. Why they write on papyrus? I don't know. You know. So we'll see that the Babylonians wrote on clay tablets, which they hardened in the sun to a rock-like consistency. So we have tons and tons and tons of hundreds of thousands of tablets, maybe even more than that. There were a lot during the Second Gulf War. There was a lot that were stolen and sold in museums and looted from some of the museums over there. So if you have any questions, you can and want to message me privately, you can do that, or if you want to ask the questions to the whole group. I'll give you a couple of more minutes, and then I'll walk through it. And I'll need about, you know, then I'll do a couple of more things in the class, and that'll be it. I'll push out the answer. So if you don't want to see it, if you want to know if you did it right, this is what I got. Oops. You know, yeah, okay. But if you want to still work on it, don't look. Okay, so here's the way that I did it. I already started with that. So 1/2 is 10.5. So if we start with 1/3, no, we start with 2/3. And that's what they started with. Sorry, I'm doing this. I keep taking, sorry. And then I try a couple more and I realize it's not going to really get me anywhere. And so I decide, okay, I'm going to punt. And this is my mechanism. I'm short 1/4, so I want to solve that. And if you do these for a while, you're just going to automatically do this. I mean, remember the equation is, sorry, 1 over n. 1 over n times 21 equals 1/4. So n is going to be equal to 21 times 4. But my guess is that they didn't use an equation. We don't know how they did it. It's doubtful they did that, but we don't know. But my thought is that they got so used to it that they just skipped this step altogether. They just knew that whatever number here, to find n, you multiply it times that number. So we got that and this. So 1 over 21 is going to be equal to 1/12 plus 1 over 84. And the 12th seems weird, but then 12 is a factor of 84. So it kind of makes sense. Is it getting better? Yep, good, okay. So not to bust your bubble, but here's what's in the tablet, in the translation. Okay, you get something like this.
Isn't it 2/21?
Yes. No, well, it's 2, we want 2 over 21, yes. And this isn't what you get, sorry. I was looking at I miscopied the thing. This is what you see if you look in the tablet. Okay. That's their answer. And it looks completely different than what we just did, but here's what's going on. 2/3 of 21 is equal to 14. So I'm going to multiply both sides by 3/2 and divide by 14. Sorry, didn't do that right. Two-thirds of 21 is equal to 14. So what we get is we get 1/14 of 21 is equal to 3/2. So you divide both sides by 14, you get 1 over 14. You multiply both sides by 3/2. And then how do we get to 1/2 from this? If 2 times 21 is 42, what's 1 over 42? Divide both sides by 1/2 and by 42, or multiply both sides by 1/2 and 42. That cancels and we get 1/42 of 14 is equal to 1/2. Sorry, I'm off the page. Pretty weird, huh? Does that make sense? So again, they do a completely different method. They do it ad hoc. So again, it's like modeling and some other things. Whatever works, whatever gets you there works. So there's a lot of flexibility here. It's not just doing it the same way every time. So the thought process here, they said, well, we know what 2/3 Okay, 2/3 of 21 is 14. So that means that 1/14 of 21 is 3/2. And then they say, well, I just need a half. So if I double 21, I get 42. So I know that that tells me that 1/42 of 14 is 1/2. So it's like each time they did this, they got better and took more and more shortcuts, and it gets harder to figure out. Okay. So if you were able to figure it out doing it the regular way, that's perfectly okay. I'm just showing you what they did. So I'll probably, for homework, you'll get a couple of these, and you'll be able to do them. Most people are able to do these pretty well, so I'm sure you will. But it might take a little bit of time to work it out, but you'll be able to get these. And I'll let you kind of use your own creativity for it. And I have one more thing to show you, and it'll just be quick. I'm not going to do any more math. I think we've had enough. But I want to show you one more thing. But before I do, it'll just take like 2 minutes. But before I do, any questions? Again, you can shout them out, or you can put them in the chat. I hope you're getting a sense of how to do this. And to me, it's the most fun part about this kind of Egyptian mathematics. And like I say, surprisingly deep. Okay. So the last share, this is the third handout. Now I'm worried that is this visible, this table? Good, okay. So I'm just going to look at one of the columns. I'm going to go to the column of 11, just because for no good reason. And so that it says divisor 11. This means that 2/11 is equal to 1/6 plus 1/66. If you look at 2/13, that's exactly what we got. 2/13 equals 1/8, 1/52, and 1/104. And we see the one that they got for over 21 and the one for 15. So this is something that what the papyrus had this in there, and it was a table of all these unit fractions up to 101. And so the scribe just worked through each one of these, and of course, as they do this, they're going to get pretty good at it. And so, this was probably like a logarithm chart, which you probably don't know what that is, but like before calculators, we had to look up logarithms in little books and charts and things like that. And the same for trig tables. To look up a trigonometric value, you had to use a table and learn how to interpolate and things like that. So, and then down here, this is sort of the what they used for unit fractions, the notation, and that little bar that this is the Eye of Horus, and so that little bar you saw over it it's the way that historians represent that. And then these are questions. I'll let you think about those, and we'll come back to these at some point. I may talk a little bit about them at the beginning of class on Tuesday. We'll have a couple of more things about the Egyptians. I'm going to post over the weekend the introductory lecture to the Babylonian mathematics, and just look at that before Tuesday. And that's it pretty much. So if you have any questions before we go, that's fine. If you want to stick around and have questions and ask them to me after class, that's fine. Stick around. Otherwise you're free to leave. But I hope you got a sense of a little bit of sense of what they were doing, not why they were doing, but like what they were doing and kind of what we're, when we look at Egyptian mathematics, kind of what we're faced with. Okay. Again, I'll have a good weekend, everybody, and I'll see you Tuesday, and it'll be ever smoother. If you think about it, you all are way more adept at this than us because you're in this environment. 15 hours a week or so, and we're in this environment, 6 to 9 hours a week. So you got more practice.
Well, have a good weekend.
Yeah, you too. Thank you. Yeah. That was Daniel, right?
No, that was Paul. But yeah, have a good weekend, Dr. Alexander.
Okay, good. Thanks. I was trying to think who that was. Yeah. I didn't have my gallery view on, so I couldn't see your lips move. Okay,
let's see.
take care, Paul.
Bye. Have a nice weekend.
Okay, thanks, Daniel.
Hello, sir. Can you hear me?
Yes, I can. Yeah.
Oh, yeah, perfect. So,
Oh, hold on just for a second, Kika.
Mhm.
Nick, did you have some questions? Are you just lingering, Nick?
That was the only question I had that I posted in the chat.
Oh, and did I answer it? Oh, no. Oh,
No, I literally just did it.
yeah. Okay. And I'll push it out with a, with an email to let you know what it is. Okay.
Okay.
Yeah. And if I forget, like, again, if I forget something in the chat, just let me know.
All right.
Okay. Thanks, Nicholas. You go by Nick or Nicholas?
Either. I've never really cared too much.
Okay.
I'm more concerned about spelling because it's not spelt normal.
Right. Yeah. Okay. I prefer Dan to Daniel for lots of reasons that I won't go into, but.
Well, in this class in particular, I'd say because there's already 2 Daniels, and not even including you.
That's right. There's like a myriad of Daniels in this class, I think.
Yep. Well, see you next Tuesday.
Okay, good. Have a good weekend. Bye-bye, Nicholas. Hey, Kika.
all right. Hello, sir. I actually have not a few, actually, just probably 1 or 2 questions. I mean, I kind of makes sense to me when I was looking at the first example, like the one with the 1 and 7.
Yeah.
I was so close with getting it. And then starting from the second one, it was just went to like blank for the 215, starting with 1/10.
Yeah, I'll go through that again.
Yeah.
So we want 2/15. And so the idea is you start out that multiplication algorithm and then cut it in half. We started with 2/3, right? Or 1/3?
No, we started with 1/10.
1/10. Okay. So 1/10 is 1 1/2.
Yep. And 1/3.
And then we go 1/3 of 1/10, and we kind of
Yeah.
luck out here. 1/3 of 1/3 of 10 is 1/30. And
Yep.
1/3 of 1.
1/3 of 1 is 1/3.
And how about 1/3 of 1/2?
1/3 of 1/2 is. Oh wait. So. Okay, I did it wrong. That's probably why I was so confused.
And that happens to equal 1/2.
I see. So you start from 1/10. Is there any particular reason they start from 1/10 or like just?
That's a good question. What
off.
do you think the reason is?
Is it because they can just divide 15?
Yeah, they share that factor of 5, so it's easier to work with.
I see.
I'm going to look through. I wish if we were in a class, I could show you this book better. But if I'm going to look at they start 2/25 by dividing by 15. They start 35 by dividing by 1/30.
Oh, it's easier to divide by that.
Right. Yeah.
Because I tried to divide by 2 as well, and I was like, oh wow, this is a very messy.
Well, yeah. If you divide by 2, let's see what happens. You get 1/2 is 7 1/2. 1/4, 3 1/2, 1/4. 1/8. Now we're getting in business. Is 1 1/2 from the 3. 1/4 and 1/8.
It looks pretty okay.
And then we don't know here, so this will be 1 over n, but here we have 1/8, right?
Yep.
So what would n be?
And would be 1 over n times 15.
Yeah.
So that would be
120.
8 times 15. 120. Wow, that's a big number.
Yeah. So see, there's more than one way to do this.
Ah, okay.
Right.
I'm sorry if you can hear the dog.
No, I didn't realize you had a dog. Is that yours?
It's not mine actually, so it's my friend, but he locked him in the cage, and for some reason she's sobbing right now. So
He wants to play. No, it's no problem.
probably yeah. But yeah, so okay, that makes sense a lot. So it's just that they want to like make it faster way because I know that this is a bigger number, and they want to just reduce the number by making factoring a larger number.
I mean, imagine this was that you had to do this. You had to go back. Let's go back to that table. Right here. You had to fill in this table, right?
Uh-huh.
You had to do all these calculations. Okay. Now, at first, you're going to be like, that's really, that's hard. And then you're going to go, oh, there's shortcuts I can take. And then you're going to go, this is a lot of work. I just want to get it done as quickly as possible.
Yep, just like anyone else.
Like anyone else, exactly. Yeah. And then you get better at it because you're doing this thing over and over again. If you went through that table and derived that table, I'm not saying I want you to do that because it would take hours, but you'd be really good at this.
I see. So yeah, I think I started again. I was just confusing by the English wording because when it says starting from 110 and then dividing by 1/3 rather than 1/2.
Yeah.
I thought I just start with 110 and just keep doing it with 1/3 and not doing it 1/2.
Yeah.
So
No, it is. I mean, that is because you start with 1/10
and then keep dividing with 1/3.
and then you divide by 1/3 rather than 1/2.
Okay. And then keep doing it there as well. So I would get like 190.
Yeah. If you needed to, but it works out. You're done after 2 steps.
Oh really? Oh,
So-
I did more.
Right? It's really nice. Yeah.
I see. Yep, I think that's all. That's the answer question. I'm just gonna need to like do it more and just like look at it more later. But yeah, that's pretty much it.
Yep. Okay.
Pretty
Good.
fun.
Good.
And also, I haven't talked to Penaton yet, so I will probably talk to him tomorrow soon.
Good.
I hope.
Yeah. There's no. I mean, it's we want to get a feeling of where you are by the end of next week, so you can drop courses if you need to.
Yep. So far it's just geometric series for Cal 2. So, and I think Professor Penaton is quite, I mean, not slow, but reasonable speed of doing it. And I just kind of have to catch up. Well, I mean, I used to be a god in calculus, but 4 years can really,
I used to be a guy. Then you'll be fine. I mean, it'll take a while, but you'll get it back. You'll get it back.
Well, it depends on me whether I want to get it back or not. So that's really a different factor.
Exactly. That's a good fact. Yeah.
Yeah. So I will try my best. And luckily, I used to work a lot, but luckily right now I've been stopped working quite a number of hours. So I do have more time to work on my own stuff, which I'm gonna use that too.
Is that a Drake job that you had?
Yeah, I work in the IT department, and Lily is just getting busy. That's why. The Zoom thing is just funny.
I know, it's crazy.
All right, and I'm just gonna disturb your evenings.
Okay.
All right, have a great weekend, sir.
Okay, you too. Sounds good. Okay. I'll see you, Kika. Have a good weekend. Talk to you next week.